Besides grams, we can do other stoichiometry problems involving other units, such as representative particles or even liters. So we're going to take a look at two other examples. We're going to work with the equation showing the electrolysis of water. So liquid water can be broken down into hydrogen gas and oxygen gas. And let's say we want to find out how many molecules of oxygen are produced when we have 29.2 grams of water decomposing. So what we have to do is list our known quantity, which is 29.2 grams of water. What are we looking to find? We want to find molecules of oxygen. So the conversion that we're going to do, we're going to start with grams of water. Then we need to convert to moles of water, because we always need to convert to moles, and then we will convert to moles of oxygen. And once we're in moles of oxygen, we can find molecules of oxygen. So we'll start with 29.2 grams of water to convert to moles. I'm going to divide by the molar mass of water, which is 18 grams. And then I need to convert to moles of oxygen. Remember, from here to here, this is where I use my mole ratio. So this is my mole ratio right here. So I look at my balanced chemical equation to find that mole ratio. I have moles of oxygen on the top because that's what I want to find. Moles of water on the bottom of my mole ratio because that's what I want to cancel out. From the balanced chemical equation, I have 1 mole of oxygen for 2 moles of water. Now I'm in moles of oxygen. Once I'm in moles of oxygen, I can find molecules of oxygen. And there are 6.02 times 10 to the 23rd molecules in 1 mole. So my problem is set up. So I have 29.2 divided by 18 divided by 2 times 6.02 times 10 to the 23rd. And I get 4.88 times 10 to the 23rd molecules of oxygen. So in these stoichiometry problems, I don't have to always start in grams. I can start with any other unit, such as molecules or liters, because I know how to convert to moles. So we can start with any unit as long as we convert to moles and then use the proper mole ratio to find the quantity that we're looking for. So the mole map that we used back in chapter 10 is still going to be really important and helpful to you in making those conversions. In our next example, and I'll change colors here and I'll put this all in blue, we're going to work with gases. So if I have nitrogen monoxide and oxygen gas, they combine together to make nitrogen dioxide gas. What I want to find out is how many liters of nitrogen dioxide are produced. When I have 34 liters of oxygen reacting with the nitrogen monoxide. I'm assuming that I'm at STP. Okay, since we're at STP, we can use our molar volume of the gas of 22.4 liters in a mole. So I'm going to start with my given quantity. 34 liters of oxygen. The first thing I need to do is convert to moles. 1 mole is 22.4 liters of oxygen. Then I need to go from oxygen to nitrogen dioxide. I want to find moles of nitrogen dioxide, so I need that proper mole ratio. This is where I'm using my mole ratio here. So I want moles of NO2, and I'm canceling out moles of oxygen. So from my balanced chemical equation, I have 2 moles of NO2 for every 1 mole of oxygen. There's my mole ratio. Now since I'm in moles of NO2, I can convert to liters of NO2. So I know that there are 22.4 liters of NO2 in 1 mole. So my problem becomes 34 divided by 22.4 times 2 times 22.4, and this will be 68 liters of NO2. Now when we look at this problem, you might notice here that we have 1 over 22.4 and 22.4 over 1. And these two units will cancel each other out. So we actually really didn't need to have them. So what this means is that if we have a problem where we have a liter to liter problem for gases at STP, if we have a liter to liter problem for gases at STP, okay, you'll notice that the 22.4 liter per mole factors cancel out. Okay, so the 22.4 liter per mole factors cancel. You don't need them. Now it's okay if you set up the problem with them. You'll just discover as you're working the problem that they will cancel out. But I wanted to point that out to you. Everything here is a gas. Our reactants are products. So we're going from liters to liters. We don't need these two conversions of 22.4 liters in a mole. So to reiterate, for any stoichiometry problem, we can convert from representative particles or liters or grams because we know how to go from all three of those things to moles. So we can solve any stoichiometry problem in any units that we would like. We just have to remember how to convert those units and how to write the proper mole ratio using the balanced chemical equations.